Hello student, welcome to Learn More Maths. Today we are going to learn about similar triangles part 2, basic proportionality theorem. It is also known as Thales theorem. So see the student what it says. What is the statement of the basic proportionality theorem? If a line is drawn parallel to one side of a triangle intersecting the other two sides, then it divides the other two sides in the same ratio. So see student what it means. Let ABC is a triangle, student. So see student, ABC is a triangle. Let ABC is a triangle, ABC. So if a line is drawn parallel to one side of a triangle, so BC, I am drawing a line that is parallel to BC. So I am drawing a line, so DE. So see student, I have drawn a line DE, so which is parallel to BC. So what it means, see here, if a line is drawn parallel to one side of a triangle intersecting the other two sides, then it divides the other two sides in the same ratio. So see student, in triangle ABC I have drawn a line segment DE which is parallel to BC, then it divides the other two sides in the same ratio. That means AD divided by DB is equal to AE divided by EC. AD divided by DB is equal to AE divided by AC. So now we have to prove this theorem, student. So before going to prove this theorem, you must have clear idea about the area of a triangle. So see student, this is the general formula to find the area of a triangle. So what is the formula, student? Area of a triangle. How can we find area of a triangle? Area of a triangle is equal to, so we know half into base into height, half into base into height. So B is base and H is height. So this is the general formula to find the area of a triangle. So see student, if let here again ABC is a triangle, student, here ABC. So area of triangle ABC is equal to, see student, if I take BC as base, then the perpendicular height onto the base, so this becomes height, let it is a D. So if I take BC as base, then AD becomes height. So see here, student, if I want to write the area of triangle ABC, half into base into height, half into, now I am taking BC as base, then AD becomes height, AD becomes height. Suppose if I want to take AC as base, then the perpendicular distance onto AC, so this becomes height, student. So this is the perpendicular distance, so this becomes height. So here let it is E. So now BE becomes height, student. BE becomes height. That you have to remember. So which side we are taking base, and the perpendicular onto the side we have to take it as height. So suppose there is a triangle, student. Let see student, this is an obtuse angled triangle. So let it is XYZ. So XYZ is an obtuse angled triangle, student. Now I want to find the area of this triangle. Suppose if I take area of triangle XYZ, so for that area of triangle XYZ, area of triangle XYZ is equal to, so see student, half into base, I want to take YZ as base, then what is the height, student? The perpendicular. So now I am extending YZ, so this is height, student. So this is height, let it is XA. So now XA becomes height. So student, for an obtuse angled triangle, height will be outside of the triangle. So that you have to remember, student. Area of triangle XYZ equal to half into YZ into XA. So now I have taken YZ as base. So this you have to remember, student. So see student, instead of writing area of triangle XYZ, so we use this symbol. So area of triangle XYZ. So instead of writing all these, we use this symbol. You think that it is area of triangle XYZ. This is a area of triangle XYZ. We use this denotation to write the area of the triangles. So that's all, student. This is about area of triangle. So now student, again to prove any theorem, we have to follow 4 steps, student. We have to follow 4 steps. So what are the 4 steps? See, student, these 4 steps we have to follow to prove this theorem. So first one, given. So this will be in the given statement. What he has given in the statement, that is given, student. So what he has given in the statement, that is given. So second one, to prove, it is also known as RTP, student, required to prove. So second one, what we have to prove, we have to write in the second step. So third one, student, construction. So see, student, if we require construction, we have to construct. So next, fourth one, student, proof. So this is the actual proof of the theorem. So for every proof of the theorem, we have to follow these 4 steps, student. See, students, what are the 4 steps? First one is given, second one is to prove, third one is a construction, fourth one is proof. So we have to follow these 4 steps to prove the basic proportionality theorem, student. So first one, given. So how can we write given for the given statement of basic proportionality theorem? So given, student, first step I am writing given. So see, student, how can we write given? So this is given, student, a triangle ABC, in which DE is parallel to BC. So intersecting AB in D, and AC in E. So see, student, this is a given. So see, student, a triangle ABC in which DE is parallel to BC, intersecting DE, AB in D, and AC in E. That is first step, given. So second one, student, to prove, what we have to prove? See, student, what we have to prove? So see, student, if DE is drawn parallel to BC, then DE divides the other 2 sides in the same ratio, that is AD by DB is equal to AE by EC. That we have to prove, student. So I am writing AD by DB is equal to AE by EC. AD by DB is equal to AE by EC. So this we have to prove, student. This is to prove. So next, construction, third, to prove this theorem. So now what I am doing, see, student, we have to join these two. So join B and E, so D and C. So now I am joining these two, students, see, these two. So joining B comma E, so joining B comma E. So next, join these two, students, C and D. So I am joining these 2 points, C and D. So this is a construction step, student. Third step, this is our third step. So if our proof required construction, student, so I am doing construction. So next, draw a perpendicular onto AB, student. So this is the perpendicular. So I am drawing a perpendicular onto AC. So again, let it is F, student. So next, draw one more perpendicular onto AC from the point D. So this is the perpendicular, student. So this is the perpendicular. So it is also a perpendicular. Let it is a G. Let it is G, student. So this is our construction, student. So what we have constructed now, we have to write in the third step, construction. So I am writing, C, student, what we have done just now. So I am writing as construction. So C, student, first joined CD and BE, joined C comma D, joined C comma D and B comma E, joined these two. Next, drawn DG perpendicular to AC and EF perpendicular to AB. So see student, next one, drawn EF is perpendicular to AB and DG is perpendicular to AC. So these are our construction, student. So construction, once again, see student, what we have done in the construction: joined B comma E and C comma D, drawn a perpendicular EF onto AB and one more perpendicular DG onto AC. So this is our construction, student. Now we have to prove the theorem, actual proof. So for that, see student, so proof. So this is actual proof. So now I want to find area of triangle ADE, student. This is triangle ADE. So area of triangle ADE. So area of triangle ADE is equal to half into base into height. This is the general principle. So now I want to take AD as base. Now I want to take AD as base. Then EF becomes height, student. EF becomes a height. If I take AD as base, then EF becomes a height. So see student, area of triangle ADE is equal to area of triangle ADE is equal to half into base into height. So half into base I am taking as AD and height EF becomes a height for this triangle. Okay. So next, again I want to find area of triangle DBE, area of triangle DBE, student. So see student, area of triangle DBE is equal to, so in the same way again half into base into height. So half into base into height. So here half into, so now again I want to take DB as the base, student, DB as the base. Then here EF becomes height again. So EF becomes height. So see student, DBE is an obtuse angled triangle, then EF becomes the height, DB into EF. So now I want to find the ratio of these two triangles, student, ratio of the areas of these two triangles, ratio of area of triangle ADE divided by area of triangle DBE, area of triangle DBE, so is equal to, so what is their left hand side? I want to find the ratio of the areas of these two triangles. I have written in the left hand side. What is there on the right hand side? So half into AD into EF divided by half into AD into EF, half into AD into EF divided by half into DB into EF. So see student, half gets cancelled, EF gets cancelled. What is there? AD divided by DB, AD divided by DB. Let it is equation number 1, student. This is equation number 1. So just I have, see here what I have done, area of triangle ADE divided by area of triangle DBE. So this is a triangle ADE, student, this is triangle DBE is equal to what? AD by divided by DB. So similarly student, we can get similarly we get, so now I want to write again area of triangle ADE divided by, so now this area of triangle ADE. Now I want to take AE as the base, student. If you take AE as the base, then DG becomes height, student. DG becomes a height, that you have to remember. So area of triangle ADE divided by area of triangle. So now I want to find the area of triangle DCE. DCE is equal to, so see student, what we get? Half into, so now for this triangle I want to take AE as the base, then DG becomes height, half into AE into DG, AE into DG divided by, for area of triangle DCE, so EC I am taking as base, then DZ becomes height, student. Again it is an obtuse angle triangle, so this is a height of triangle DCE, half into EC into DZ. So see student, half gets cancelled, DZ gets cancelled, so you can get AE divided by EC, AE divided by EC. Let it is equation number 2, student. So see student, now triangle DBE and triangle DCE, these two triangles are on the same base DE and between the two parallel lines. So there is a statement, student, what it's the, see student, if any two triangles are on the same base and between two parallel lines, then the areas of those two triangles are equal. So here student, the triangle DBE and the triangle CDE are on the same base and between two parallels, hence the areas of these two triangles are equal. So see student, I am writing triangles DBE comma DCE are on the same base and between two parallel lines, DE and BC, So see student, triangle DBE and triangle DCE are on the same base and between two parallel lines, hence the area of triangle DBE is equal to area of triangle DCE. Therefore, area of triangle DBE is equal to area of triangle DCE. So now I want to write the reciprocal of this, student. See how can we write a reciprocal. 1 by area of triangle DBE, 1 by area of triangle DBE is equal to, on the right hand side also, 1 by area of triangle DCE. So since reciprocals I have written, student, reciprocals. So just we have to interchange the numerator as denominator and the denominator as a numerator. So area of triangle DB, what is there in the denominator? There will be 1 in the denominator. So I have written 1 in the numerator, then it is in the denominator. So this is the reciprocal. So now see student, equation 1 and 2 of left hand sides of equation 1 and 2. The left hand side of equation 1 is area of triangle ADE by area of triangle DBE. So the left hand side of equation 2 is area of triangle ADE by area of triangle DCE. So the numerators are same on the left hand sides of both the equations. So if I multiply entire this equation by area of triangle ADE. So see student, let it is equation number 3, student, multiplying equation 3, multiplying equation 3 by area of triangle ADE on both sides, we get. So see student, this is equation number 3. Now I am multiplying equation 3 by area of triangle ADE on both sides. So what we get, students, see here, area of, so 1 into area of triangle ADE, that is area of triangle ADE divided by, what is there in the denominator? Area of triangle DBE. So in the same way, second one, so area of triangle DCE, area of triangle DCE. So sorry, so area of triangle, what is there? 1 is there, 1 into area of triangle ADE, that is again area of triangle ADE divided by, what is there in the denominator? Area of triangle DCE, area of triangle DCE. So see student, now the left hand sides of equation 1 and equation 2 are equal. Now we can equalize the right hand sides. The right hand sides are AD by DB is equal to AE by EC. So this is the left hand side of equation 1, area of triangle ADE by area of triangle DBE. See student, area of triangle ADE by area of triangle DBE. So next this is the left hand side of equation 2, area of triangle ADE by area of triangle DCE. So from equations 1 and 2, therefore from equations 1 and 2, from equations 1 and 2 we get, so equations 1 and 2 left hand sides are equal student, we can equalize the right hand sides. What are the right hand sides? AD by DB is equal to AE by EC. AD by DB is equal to AE by EC. This we have to prove student, hence proved, hence proved. So that's all. This is the proof of a basic proportionality theorem student. So just you have to remember the statement student, based upon basic proportionality theorem. He is giving problems on basic proportionality theorem, application of basic proportionality theorem. So student, in the next class we will learn problems based on basic proportionality theorem. That's all today's class student.